Hello, Internet! In this here video, we're going to be going over the strategy pattern, also known as the policy pattern, although I've literally never ever heard anyone ever refer to this pattern as the policy pattern, but whatever. So I've created a basic cheap little Spring Boot application. You'll be able to get the start files in the doobly-doo, or can go to springinitializer.com and, do your Spring stuff, but go to the description, it's easier. The only thing that if of note is that this is a basic Spring Boot application. I'm using 2.4.1, and the other thing is that I've got Lombok installed. Now, this is the bit to pay attention to because I always get comments about this. If you're seeing me do something like use a getter or use a constructor, right, and I haven't created the constructor, it's because I've used Lombok and I'll have annotated the class. I'll try and be clear about this as we go on because it's the thing that everyone always misses because I mentioned it once in the video, but I'll try and mention it many, many times. Right, so strategy application. Firstly, what is the strategy pattern? So the strategy pattern is a behavioural design pattern, right, that enables you to have an algorithm that you can easily vary, right? For example, you might have well, in the example we're going to go over, we're going to be talking about tax rates because that's going to be thrilling. And what you might do, right, is you might have a series of code, right, that does this. Let's just create a little private function. We'll call it private static void exemplar. And in here, we're going to say something like, we've got an employee, okay? And let's first create the employee. No, let's not create the employee first. Let's just pretend we've created the employee. So we'll do final employee. It's going to moan because it doesn't have that. So new employee. Like that. And then let's say, right, we wanted to calculate the tax this employee pays. And let's say the employee has a salary. So what you do is you do something like this. You'd have to do if, let's say, employee is higher rate payer. So in the UK, we have different bands of tax. So you have lower rates, higher rates, additional rates of tax, and so on and so forth. So you'd have to do something like this. Then you do the, calculation here. And then you'd also have something like if employee is lower rate payer. And you could do some calculating here. And you could also, in here, you might say something like, okay, what's the tax-free amount? So you might do stuff like that's slightly different. So if they're a low rate taxpayer, they might have, well, everyone has a tax-free amount. But let's say, for example, that they don't if you're a higher rate payer. So you have a tax-free amount, and then you do a calculation based on something like that. So obviously, I haven't actually written any code here that's useful or doing anything. But this is the sort of thing that a strategy pattern is designed to solve. Because at the moment, what we have to do, right, is we have to have all these conditional things, these if statements that are going to, encapsulate. Well, they're not even encapsulating anything. What they're doing is they're doing the logic that we're going to need for this particular calculation for, calculating tax rates and what have you. Now, as we go on, these are going to get more complicated because there are additional things that we might want to add to them over time, or maybe we want to have different types, and maybe there's a custom rate that you might want to add at some point. But the point is, this will get messy quickly because this will have multiple if statements that go inside it, and this will have multiple if statements that go inside it. So really, we want to encapsulate this. And one way we can do this is using the strategy pattern. So let's create the strategy pattern now, and we're going to implement it, and I'm going to show you two ways to do this. The second way is far superior to the first way, but the first way I'm going to show you how to do it is the way you will have maybe seen before. It's the common way, it's the easiest one to recognize, but there's another way of doing it which is also a strategy pattern, but you're not necessarily going to recognize it straight away because you probably haven't seen it before. So let's start off by creating a cheeky little package. We'll call it model, and I'll create that employee class. Java class, and we'll just call it employee. Yeah, we'll add it to Git. Okay, first thing I'm going to do is I'm going to add some gubbins to this. All-args constructor, that's from Lombok. No, lombok.all-args constructor. See the start of the video if you don't know what Lombok is. And then I also want to have maybe a getter, and I also maybe want to have builder, and then I want to set to builder true. To builder is basically a way of taking an existing object and creating a builder object of that object with all the fields we have, and then we can mutate various bits to create a whole new object based on an original object. Getter, that's just your setters. Well, it's not the setters, it's just the getters. We don't care about setters. The next thing I'm going to have in this employee class is basically we're going to have a non-null, and again that's a Lombok annotation, big decimal, and it's going to be the employee's salary. Another non-null will be a private final, and we'll call it a tax strategy, like this. And then we're going to have a cheeky little private method, and all this private, oh no, it's not a private method, it's just a public method, should I say. Return a big decimal, and it'll be something like calculate net salary. So this is going to be common to all of the employees. So we're going to say tax strategy. What will we do? We'll call it calculate, and then we'll do this dot salary. Okay, now we haven't created this tax strategy yet, obviously, but what this means is that at the moment, when we've created this tax strategy, all we have to do for any given employee is just say, calculate the net salary, and it will take whatever tax rates they have, give it their salary, and it will calculate their net salary, right? So we don't have to do any logic. There's nothing there. We have all the logic in the strategy, and I'll show you how we can do that now using a pretty simple way of doing it. So this is the common way of doing it. We're going to create for the purpose of this, we'll create a cheeky little enum. I'll call it rate, and we'll do lower, higher. Keep it nice and simple. Then what we need to do is I'm going to create a new package, and I'm going to call this package strategy. You don't have to call it strategy, you could call it something else, but this is just so it's clear where the strategy pattern is. And we're going to create, do we want to create an interface? Yeah, let's create a cheeky little interface. We'll create an interface for this. We'll definitely create an interface for the second way of implementing this, but we'll just create one now as well. Oh, if I could only spell. Still doesn't look right, oh well. So this is going to be the interface tax strategy, and this is going to have that one method we talked about. The method is going to return a big decimal, and it's going to be calculate, and it's going to take a big decimal, and that'll be the salary, like that. Cool. Now in the strategy pattern, class, we're going to create this pattern right now. So the way we need to do this is we need to create a new class, and actually we don't want this to be an interface. I was totally talking out of my arse. This needs to be a class. Sorry, I got completely confused there. I'm an idiot. Right, so what we need to have is we're going to have, this will be extra cheeky, and it will be a public method, and it will be calculate, and we'll make this final, like that. Yes. So what we're going to do then is we'll have this calculate method. Now, what are the fields that are going to be on here? The fields that are going to be on the tax strategy are going to be, we'll have a private final rate. So that's our enum. We'll have rate. And what's going to happen here is that when you create this tax strategy, you give it the rate, and it's going to use the rate to calculate the right salary. So we then want to have some percentages for the rates. So we'll say something like private, static final, big decimal, and we'll say lower rate, and this will be big decimal, value of, and we'll say 0.2. I don't know if that's correct in the UK, I have not a clue. These are just noddy examples. And then we'll have a higher rate one, and we'll make that 40%. And then what we're going to do in here, this calculate method, the implementation is going to be pretty simple. All it's going to be is a switch statement where it takes the rate, and then we'll do something like case higher is going to be return something like what will it be? It will be something like salary subtract salary multiply by the higher rate. Okay, so what we're going to do here is we're going to take the salary and we're going to take off the amount of tax that they pay. So salary multiplied by the tax rate will be the amount of tax that they'll pay. So taking that away from the salary will be the net rate. And of course, in this case, we want to do lower as well, and this will be pretty much the exact same thing. Salary subtract salary multiply by the lower rate. I probably should have just copied the entire line, but I didn't. Okay, sirrah. And then we want to have a default one just in case, and this will just be something like return big decimal 0. We should probably throw an error or something if something like that happens, but I don't really care in this case because this is an example. So you may notice there are a few problems with this to begin with. So like I say, this is the first way of implementing the strategy pattern, and it's not the best way of doing it. So what we'll do is we'll look at the problems now. So problem 1 is that these things are something that you could arguably use for configuration instead. So you just have a rate and then you just configure those things. The problem, of course, is that each employee has different, will be part of a different band. So we really need this sort of switch statement here. Another problem here is that if we want to add another one, what do we have to do? We have to come into this class, we have to break it, right, which violates the solid principles. We have to actually, take the class and add some new stuff. So we could do something like this, and we say, what would it be? So additional. Oh, I don't know if I spell additional. Good God. Still looks wrong. So you could do something like this, and you could add a new one, and then what we've got to do is we're going to add a new thing down here, which is a problem, because now we've got to change everything. So, we haven't got to change everything, but we've got to mutate logic elsewhere, which is a problem. We've got to update our tests. We don't necessarily catch that we might not have caught all of the possible cases. So this is not a great solution. But let's just look at how this actually is going to work. So if we go to the strategy application, come over here, we're going to create a new employee. And we'll do something like this. We'll import that class and we'll say, so let's get rid of this. We don't care about this now. What we're going to do instead is we'll create this new employee and we'll say that the employee has a salary of, let's say, big decimal. We'll make things simple. So I'll say 100K. And then we will give them a new tax strategy. And we'll say rate higher. Okay. So we'll do something like this. Hire employee. Okay, and then we'll do something like this as well. We'll do lower employee. So in the case of this now, if we have 2 employees that have different rates, all we need to do is just give them different rates, right? And the employee class will calculate everything for us. Okay. This is, why is it moaning? Oh yes, I haven't imported this. There we go. Pip pow. That's stop moaning. Good stuff. Okay, so let's just have a look at what this looks like. So we'll do system out, print line, and we'll do something like higher rate employee. System out, print line, do higher employee, calculate net salary. And then here we'll do lower rate employee, and then lower employee. Now what we're expecting, of course, is that the lower rate was 20%, and the higher rate is 40%. So the rate we're going to see here is going to be £60,000 because 40 minus 100,000 is 40,000. So 60,000, and then this one's going to be 80,000. Obviously, they have the same salary, so this is a weird example, but it doesn't matter. We'll run this. Hopefully, I haven't made any egregious errors, and it won't compile, but it's going to compile. I have 100% faith. And no, I don't. Everyone who's ever seen one of my videos before knows I never get things right the first time. Oh my god, what the hell? Oh, it's not moaning. Oh, is it moaning? I don't know. Oh! Oh, yes. No, I have made an egregious error. You see this here? I haven't called this. So it's not actually outputted a goddamn thing. We'll try again. Attempt 2. Come on. It's going to compile. Obviously, it's going to compile. We've just seen it compile. But let's have a goosey gander. Okay, so it's spring. So here we go. Higher rate employee, what did I say? 60k. And then lower rate employee, 80k. Fine. That's all good. So now we've seen this tax strategy, right? Now let's go and have a look at another way of doing the tax strategy, because this is terrible. This isn't good. Like I say, if we need to update this at any point, then we've got to come in here and we've got to add to here. We've probably got to add to the rate class as well and add a new enum. And then you might have a case where it's like, oh, well, you've got someone who's higher but also got these things as well. This is not good. This is terrible. So there's too many things that can go wrong with this. So let's do it differently. Let's have a look at another way we can do this. So what I'm going to do is I'm going to delete the rate class. We don't need that anymore. Delete, doesn't matter. We'll get rid of this. And what we're going to do is we're going to turn this back into what it was originally, which is an interface, because I got it completely wrong. We'll do an interface, get rid of that, make that say E, because it should do. Get rid of the public from here, get rid of this, get rid of final from here, we don't need that there. And there we go. This is what our tax strategy interface is going to look like. Basically, we're going to have a tax strategy. We're going to have things that implement tax strategy. Now, this is, in Java, this is a functional interface. Why is it a functional interface? It has a single method. That means it's a functional interface. What that means is we can replace this interface, its implementation, we can replace it with a Lambda. I'll show you what that looks like and why that's so awesome later. Just something to be aware of at the moment. Okay, so we have this tax strategy. Now, let's actually start creating some of the strategies. So the way we can do this is, let's say we say lower rate tax or something like that. And this is going to implement tax strategy. Okay, and IntelliJ is moaning because we haven't implemented the methods. We're going to do that now. Okay, so how do we do this? Well, all we need to do is we need to just do something like what we did before. So private static final, big decimal, and this will be rate, and then it will be big decimal value of 0.2, like that. And then, of course, all this is going to do is return, what is it, salary, subtract salary multiplied by, in this case, rate. Okay, so now I've got this new class that does this. We also will add a all args constructor. There's no argument, so it's fine. We could just use the default, but I'm going to add it anyway. If I copy this now, I can do a cheeky little paste, and we will do higher rate tax. Okay, now for higher rate tax, all I need to do is do that. So now I've got a separate class that's got a separate value. Now, what I was saying earlier is that we could have these things configured, but the point of this, and you might say, well, you know, you want to configure it and then you can just change it at runtime or whatever. The problem with that is that this is a simplified solution. So like I said, there could be other things that the higher rate tax strategy does. So it might say, oh, right, so, you know, remove deductions or something like that. Whereas the lower rate one might not do that. So we can, you know, alter these strategies much simpler. So now we've got these two strategies, lower and higher rate, that are both encapsulated, which is great. So if we come over to the employee class now, we shouldn't need to change anything here. Everything's fine. We've still got the tax strategy, benefit of using an interface, or actually the fact that it's just called an interface now. So whatever it is, this class has no idea what its tax strategy is. It just knows it has a tax strategy that has a method called calculate. Okay? And all it's going to do is call calculate on that. And whatever tax strategy it's got will be used to calculate the net salary. So coming over to the strategy application, it's going to be moaning because we've now got this thing called rate that doesn't exist. But what we can do now is instead of saying new tax strategy and giving it the rate, we can do this. We can say new, in this case it's the higher rate tax strategy. So just do higher rate tax like that. And then we'll do this as well. Coming back, new lower rate tax. Okay, and now, so what did we get before? We got 6,000, 60,000 and 80,000. So we run it again, assuming I haven't got anything, completely tits up. This should work exactly the same as before. And it does. Bing, bing, bow. I don't know what that noise was I've just made there. Whatever. So now we see this works. Now, what's the benefit of this? Of doing it this way? Well, we have this easily defined, right? This means that, like I say, the employee class has no idea what the tax strategy is. We give it to that when we construct the employee. But what if we wanted to create a special case or a new case, for example? Well, what we can do is we can do this. We could do final employee, and we'll do special case, and we'll do new employee, and we'll do something like big decimal value of 100k again. But instead of giving it a new tax strategy that we've already defined here in the model, in the strategy class, we can do this. Give it a lambda. The lambda's going to take what? It's going to take a salary, because that's what it takes. So we'll just give it the variable salary, like this. And I don't need that bracket, actually. All we need to do now is we can do something like salary, subtract, salary, multiply, and then we can give it some arbitrary value. So I could say something like big decimal, value of 0.1. So this guy is paying 1% tax. Okay, so their salary, net salary, is going to be 99,000. So we'll switch this to special case. And so now, if we run this again, what we've just done is we've switched out the algorithm that's used to calculate the net salary of this particular employee without actually having to do anything. See that? Oh, I've got it wrong. That's 10%. So 90,000. Yeah, my mathematics and arithmetic is terrible. So I was wrong, but you can see how we've just created this whole new thing. This here is a tax strategy. It's just not one that we've defined anywhere because we didn't need to. We can just substitute it because this is a functional interface. It's got one method, which means Java will let you swap out a lambda for it. And of course, if we wanted to, we can just keep adding more of these strategies that can just get used as and when. So we can say, okay, right, so we've got the higher rate taxpayer, so let's, and I'm going to try and spell this right now, additional rate tax. Okay, and then all we need to do for the additional rate tax is do something like this. Now we can come back to our, where is it, this thing, and we can do something like, we'll copy all that, and we'll do pip pip pow. We don't want that to be that. Additional, and go all the way to the end. Additional rate. Okay, now we've got the additional rate taxpayer as well. So we're going to have four things come out. This last one obviously is going to come out with, what is it, 55,000 or something like that. And of course, now, look at that. This is I'm really belabouring the point here, but this is what the strategy pattern enables you to do. We haven't had to modify anything about the employee class. Okay, so if we were doing this normally, without the tax strategy, we'd have to be doing stuff like this. Like I said earlier, we'd be doing stuff like salary, if rate higher or whatever, then you do this, or you might do it as a switch statement. But either way, it wouldn't be very good. It would violate solid principles, and this is a much better solution. It's encapsulated. We can add new things. The clients can decide at runtime when they create their actual classes, when they actually instantiate a class, what that class should do, so they can change the behavior of the class by just changing the algorithm that's used. And that is a very belabored explanation of the strategy pattern. So if you have any questions, let me know in the doobly-doo. I'll try and answer them, although YouTube for some reason stopped telling me when I have comments, so I'll try and get to them as fast as possible, but YouTube. Yes, I think that's everything. The code should be in the doobly-doo. Au revoir, arrivederci, guten tag, konnichiwa, ta-ta.